Hello, my name is Brian Walker with Copper Mountain Technologies. Today I want to show how a calibration of our multi-port VNA can be done. This is the SN5090. It's a 9 gigahertz 16-port VNA. That's what I have on the table. Of course, it also comes in 6, 8, 10, 12, and 14 port variations. This one is fully populated for 16 ports. Today I'm going to do a calibration of the first 4 ports to measure a splitter, and then I'm going to use ports 7 and 8 to make a 2-port measurement of a filter at different frequencies. So I'm going to set this up. Let's do that calibration. I'm going to use 2 channels because the frequencies of the measurements are different. And let's be clear, channels are like 2 separate VNAs. You can have different frequencies, you can have different number of points, different IF bandwidths, all of that. So it's very handy for doing the kind of setup that I want to do here. I have already attached the first 4 ports to this 4-port ACM, and let's go ahead and do that calibration. So I'll go to the calibration menu. I will say calibrate. And I'm going to add a configuration. And I'll select ports 1, 2, 3, and 4. Oh, actually, before I do this, let me back up and change the range. The splitter is only good to 6 gigahertz, so we'll make it stop there, 6 gigahertz. And the starting 300 kilohertz is fine. We can also change the number of points to 1601. So it's important to get all this set up before you do your calibration. So back to calibrate. Configuration 3 is what I started. We'll do ports 1, 2, 3, and 4. We're going to use an ACM, and this is going to ask me some questions. The connectors are going to be 3.5 millimeter. The genders on the cables are female, or on the DUT are female. And yeah, actually, I should be a little more clear. It's the Cal standard gender that we're talking about here. So the ACM has female connectors. So let's go ahead and start that automatic calibration. And it will go through the first 4 ports. All right, we'll apply that calibration. So now we have a 4-port calibration completed for these first 4 cables, ports 1, 2, 3, and 4. Now we're going to add a new channel. And in this, we're going to do our calibration for a filter. And the filter is at about 4 gigahertz. We're going to start at 3.4 gigahertz. We're going to stop at 4.6 gigahertz. I'll have 1601 points. And we're going to use a 1 kilohertz IF bandwidth in order to have the noise floor be a little bit lower. And we're going to attach the other 2 cables, which we're going to use to measure the filter. And those are on ports 7 and 8. Okay, so we're ready to do the second calibration. I have this channel selected, and I'll go to calibrate. I'm going to add a new configuration, and I'm going to calibrate ports 7 and 8. It'll be an ACM calibration. Again, these will be 3.5 millimeter. Gender is female on the ACM. And yes, we are ready to start. I'll apply that. And now I have 2 calibrations. The left-hand side is calibrated from 300 kilohertz to 6 gigahertz with 1601 points. The right-hand side is calibrated from 3.4 gigahertz to 4.6 gigahertz in order to measure this filter. The panel on the left-hand side is meant to measure the splitter, which is fairly broadband, but it does stop at 6 gigahertz. This is a 9 gigahertz VNA, so we could measure beyond that, but we don't want to in order to test this splitter. So you can see how easy it was to group the ports into a 4-port measurement and a 2-port measurement to do this. Clearly, I could have done a full 16-port calibration or a full 8-port calibration in this case, and just hooked the first 4 up to the splitter and the last 2 to the filter, and I could have done that. But that would take longer because it's exciting all the ports. It's exciting the 2 ports which are not being used. Plus, it would be measuring from port 1 to port 7, port 1 to port 8, port 2 to port 7, and so forth. Grouping the ports in this fashion allows you to do a separate 4-port and separate 2-port measurement with calibrations for each. So this is the most efficient way to do that. And I could add 3-port measurements and another couple of 2-port measurements for the other connectors. It allows you to do an awful lot simultaneously. The software is pretty easy to use. You could see that I went through this calibration quite quickly to do a fairly sophisticated measurement. We'll then use this measurement to make these, to measure the splitter and the filter in a subsequent video. For now, I just wanted to show you the simple method to do calibration using an ACM. I could also have used a mechanical calibration kit and done open, short, load, and throughs on the ports, but this ACM makes the process a lot easier. I hope this is informative, and for more information, please visit our website at coppermountaintech.com, and there will be lots of other videos. Thank you very much.